Welcome back. In this video, we're going to look at a table of values that shows Washington state population in millions from 1980 to 2010. We see that we start in 1980, and so that will be time equals 0. And we know that because it defines t years since 1980. So we always start at time equals 0 where it specifies. And these dates are listed in increments of 5. And so that makes it rather convenient. We need to find the linear model for y equals at plus b, where x is like time, and a is your slope and b is your y-intercept. We need to round a and b to 2 decimal places. So let's start with a regression model. Start out with clearing anything that was in your tables. Clear anything that was in your main window. Go to Stat, Edit, and clear your lists. And now let's enter our new data. 0, 5, 10, 15, 20, 25, and 30. In our second list, we'll have 4.23, 4.46, 5.02, 5.47, 5.89, and 6.26. And it looks like I have made an error because I have gone all the way up to 30, but I don't have a digit there. So hopefully you noticed that I had my calculator sitting over the top of my last data point. So that was a good way to check that I was still getting everything listed. So my last data point is 6.81. Enter. Now my data is entered, so I'll do second quit. Then I'll go to Stat, Calc, and then we're asked for linear regression. So we'll go to linreg and see we have ax plus b. So that is the regression model we want to use. And we'll hit enter. Enter, 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 calculate, enter, and there is the equation. We are supposed to round to 2 decimal places, so we will have a equals 0.09, and b equals 4.14. And so now we could write the equation of this line. We need to explain the meaning of the coefficient a and b in your linear model using everyday language. Well, we would say that in 1980, the Washington state population is, or was, 4.23 million. And it looks like every year the population increases by 4.14 million. And it looks like every year the population increases by 0.09 million. In 1980, the Washington state population was 4.23 million. However, approximations approximately 4.14 million. And this is because when we calculate the approximations, we have to use the equation. Use equation. So this is what the table says is true, but we need to use the equation, so we need to use this to give our values. That's why we say it increases by 0.09 million each year. Find the exponential model. So now we're going to use a different model using the same data points, but we're going to use an exponential model to approximate the growth of the population in Washington state. So we'll go back to Stat, Calc, and we're going to arrow down to exponential regression. Hit enter a few times, calculate, and we now have the exponential regression. We again round A to 2 decimal places, so A will be 4.22 and B is 1.02. Explain the meaning of the coefficient A and B in your exponential model using everyday language. It looks like in this model, our initial population approximately approximately 4.22 million people lived in Washington in 1980. And the population is growing by this value here, or 2% per year. So notice that I used the equation to define the statement. Now we need to use the exponential model to find Washington state's population in 2020. So we would use how long since 1980 that's been, which is 40 years. So we'll substitute that in to our equation. So y equals 4.22 times 1.02 raised to the 40. And that will give us our value. So let's calculate that. 4.22 times 1.02 raised to the 40. And that gives me 9.31. Well, round to 32. So 9.32 million. Use your exponential model to determine when Washington state's population will reach 10 million. now we can go to y equals, click vars, variables, arrow down to stat, hit enter, go over to equation, and then regression equation, hit enter again, and now graph. Not very helpful. So let's go to zoom and let's go down to 9. So it calculates zoom stat. This looks way more linear than exponential, doesn't it? This is why it can be helpful to look at your data points when you're calculating this stuff. And then I'm going to change my window so that the highest output is maybe 12. And I'm going to guess that if we're really close to 10 million in year 40, that if I go a few more years out, I'll be plenty good for being able to calculate this. So let's make my X max, instead of 33 years, let's make it 45 years. Now let's graph it. It doesn't look like it's growing that quickly, does it? Let me graph y equals, how about 10? Y equals 10. And then let's graph that. Now I can see right away that that's not reached yet. So I need to make my window a little bigger so that more time has gone by before I will be able to find when the population is at 10 million. So I'm going to make my X max 66 years instead and see what happens. There we go. So this intersection right here is when time has passed long enough for the population to grow to 10 million. So I'm going to hit trace, and it looks like it's hopping along the data point, so I'm going to arrow up, arrow down. It really doesn't matter, let's just use that. And then I'm going to arrow over to where the intersection happens to be. And that will tell me how many years have passed. Okay, so 53.5 years would have to pass before the population would hit 10 million.